Now we will finish the Chapter 2 practice test in this video. The first video looked at questions 1 through 10. Now we'll look at 11 through 20. 11 and 12 will both be multiple choice on the actual test, so you don't have to worry about remembering all of the different things that need to be written down or how it needs to be written. 11 says f of x equals x squared, g of x is equal to x plus 4, that quantity squared, and h of x is equal to an x squared plus 4. How do you get the graphs of g of h from f? Well, when you have the number wedged inside of what gives the function its name. So this is an x squared, and you can see x plus 4 is inside of what's being squared. If it's inside of the function, that is going to move your function left or right. If it's outside, like it is with h, outside of what gives it its name, because it's an x squared, and then plus on the outside the 4, that's going to move it up or down. So we can get g from f by taking my f and translating it 4 units to the left, because it's actually going to go the opposite way that it looks when you're talking about being inside of the function. And so you can see he's a 5, and this is up, and so that's not going to work. And so I only can be between A and B. Oh, can't be B, can't be A. So I'm only left with B. And so G is obtained by taking the graph of f and shifting it 4 units to the left, which means out here, when it's outside of the function, we go up or down, but we only had the one choice left, that it was obtained by moving the graph 4 units up. Number 12 says you have y equals 4 times f of x plus 5 minus a 3. How can you get the function, the graph of the function, if I gave you just f? Well, it doesn't really matter what f looks like or what f is. You would move it to the left 5 units, and so let's look for the 5s. Vertical factor? No. Right 5? No. And so I only am left with D and E. And we know that outside of the function is going to go up or down the way that you would think. So this is going to go down 3 units, and so that leaves me with E. F of x, whatever it is, would go left 5 units, down 3 units, and then we didn't even need to talk about the 4, but it would stretch it. When you multiply by a number, it either stretches it or spreads it. It kind of depends on what the function looks like, as whether or not it gets wider or more narrow, but it will do something with a stretch or a squeeze. Number 13 gives you a picture of the two graphs and says, how would you get the red graph given that you will have the x squared here over in your blue graph? Well, let's look at where our vertex is, our turning point. This turning point is going from 0, 0 over to 4, 2. So I would have to go up 2 units and to the right 4 units. So I move things left or right by putting a number on the inside. If I want to go right, it actually has to look like it's going to the left. I move things up or down by adding a number to the outside and getting that to go up. I just say plus 2. To get it to go down, it would be minus 2. And I want it to go up 2, so I'll say plus 2. So y equals x minus 4, that quantity squared, plus 2. But our blue graph is also opening up, while our red graph is opening down. And so to get something to flip upside down, that is a negative out front. And so I have negative times the quantity x minus 4 squared plus 2. And you might be saying, that is not what it says on the answer key. That's true, but that's because they factored it out. And so what they did was said, I'll FOIL this, so I got x squared minus 4x, and another minus 4x is minus 8x. Negative 4 times negative 4 is a positive 16. When I distribute, I get a negative x squared plus 8x. That would be a minus 16, but I have a plus 2, and that's where the negative 14 comes in. You do not need to distribute on the actual test. Factored form is fine with me. Number 14. I have x squared again, and then I do something to it, and I get this. What did you do to the x squared graph to get this red graph? Well, we know that x squared looks like this one right above it, right? The blue one. I'm going through the origin, opening up. I'm still opening up, but I'm not going through the origin anymore. Now my turning point is down 4 units. So if I come to my options, it can't be anything with a plus 4. So I have a couple here that don't have a plus 4. I got a 1/5 x squared minus 4, a 5x squared minus 4, and then I had this negative 5x squared. Well, it can't be negative because it's opening up. So I'm between 5x squared and a 1/5. Now you could graph each of these in your calculator, but when you have a value of a that is greater than a 1, that's going to squeeze it together. And when you have a value for a that is in between a and 1, that's going to make it wider. And if you look back up at the blue graph, see how much more narrow that is compared to the red one that we have on 14? So it needs to be C, 1/5 x squared minus 4. Using 4x minus 4 equaling f of x and g of x being a 5 minus x squared, evaluate the expression g of f of 3. With composite functions, you take the second one and you put it into the first one. So anywhere I see a x in my g, I'm going to take the x out and I'm going to plug that in. So the first thing I'm going to do here is say 5 minus, and now instead of x squared, it's going to be 4x minus 4, that quantity squared. But also this time, I have a 3 in here, not an x. So I need to take the x out and plug a 3 in. And so when I plug in a 3, I get 5 minus 4 times 3 minus the 4, and then square it. And then we're just going to simplify this expression. 5 minus 12 minus 4 squared. Well, 12 minus 4 is 8. And 8 squared is 64. And that's how for number 15 you get a negative 59. For number 16, we want to do our subtraction, and we don't have any value to plug in. So all I need to do is actually find the new expression. I want f minus g, so 8x squared plus 6x minus, put this in parentheses, a negative 9x squared plus 1. The parentheses are important because you're not just subtracting the negative 9x, but this whole expression. And so you'll need to distribute the negative sign. Everybody always forgets the negative sign. And then you'll combine like terms. I have an 8x squared and a 9x squared. That's 17x squared. And the 6x and the minus 1 don't have anybody until now. I am all finished there. 17 is another way that you can write a composite. This says take f and put it into g. It actually says g of f of x, just written in a different way than what we saw in number 15. Right? In 15, they use the little open dot, g of f of 3, or g of f of x. This is the same exact thing. Take f, plug it in to G. So I'm going to take f, and anywhere I see an x here, I'm going to plug that in. So G of f of x. I tend not to write this version a lot because the parentheses I think look messy. I tend to use the open DA. Absolute value of now of x minus 9 plus 8. It's good habit to put anything that you're subbing in parentheses just in case you have to distribute some stuff. Although we have a positive 1 here, so I'm just going to have x minus 9 plus 8, also known as x minus 1 in my absolute value bars. Number 18, find the inverse of a function. To find the inverse when you're given the actual equation, what you're going to do is swap your x and y. Remember, f of x is just a fancy way to say y. And so instead of y equaling x to the 9th plus 8, we're going to say x equals y to the 9th plus 8. And now I'm going to solve for y. So I'm going to subtract 8 from both sides. And I have y to the 9th. Well, how do you undo a 9th power? The same way you undo a second or a third. If it was squared, we'd take a square root. If it was to the 3rd power, we'd take the 3rd root. In this case, we will take the 9th root. And so I have the 9th root. This little index over here tells us what root we're taking of x minus 8 equal to y. Number 19, is f of x a one-to-one function? And the function that we're looking at is x plus 11 over an x plus 5. How do you know it's a one-to-one? You're a one-to-one function if your f of x is a function and also your inverse is a function. Now, this is going to be a little bit messy if you wanted to find this by hand, right? If you could find it where you swap the x's with the y's. But what we could do is use our calculator to help us out. You have two options here. I can go into my y1 and say x plus 11 in parentheses over, in parentheses, the x plus 5. And now when I graph that, I'll see my original, and there he comes. This line going up and down, you may or may not see on yours. It's the asymptote. The virtual TI does not let me turn it off, so if you don't see it, it's not that your graph is wrong. This line is actually not a part of your graph. That's an error at the -5, which you can see in here. That means it's not a part of your domain. Is this a function? Well, if I were to drag my pen across, it would indeed pass the vertical line test. So yay, f of x is indeed a function. So now it will be a one-to-one function if when I graph the inverse, it also passes the vertical line test. But I don't actually want to graph it. I'm going to use the horizontal line test. So if I were to take my pencil and lay it the other way, let me take a little screenshot so I can move it over. And insert it into here. Very tiny. You can see that it passes this right this way. That's no problem. Let's check it the other way and check our horizontal line test. And sure enough, we are good to go. Any line that I pass it through, it's only going to hit once. And so since it passes the vertical and the horizontal line test, that means my f of x is a function and my f inverse is a function. And that means he's a one-to-one function. The other thing that you could do, although it will look a little bit messy for this particular graph, is that from the main screen, you can say second program to bring up your draw menu. Go down to draw INV, hit vars, go over to y vars, choose function and then y1, and then when you hit enter, it will actually graph the other one. But you can see it looks pretty messy. And then you can go through and do the vertical line test again. Rationals tend to be pretty ugly graphs, so I would recommend using the horizontal and the vertical line test. Number 20, finally, last one. Use composite functions to show that these two guys are inverses of one another. All right, so if these two are indeed inverses, when you plug one into the other using composites, the expression is going to result to being equal to just an x. It's going to simplify down to just an x. Now, technically, you should check them both ways. A lot of times we don't, but you really should check them both ways. You should say f of g of x, and you should find g of f of x, because those two things don't have to be the same. And if these are both turn out to be equal to just an x, then they're inverses. So let's find f of g. I'm going to take g, and I'm going to plug it into here everywhere I see an x. So f of g of x is going to be, instead of x to the third power, x minus 5 to the 1/3, and then raise that to the third. Now, when I clean this up, no, that's not what it would be. That would be this one. Yes, it would. I'm not done yet. Plus 5. That's what I was missing. So I have 1/3 times a 3. That's a 1. So I have x minus 5. And then, of course, I have this plus 5 out here. And then minus 5 and the plus 5 will add out. And indeed, it's equal to just x. All right, let's go the other way. Let's see if g of f of x is going to simplify down to just an x. So everywhere I see an x in my g, I'm going to plug this in. So this side's going to be x to the third plus 5, then minus 5 to the 1/3. Well, x plus 5 and x minus 5 is 0. So I have x to the third and then take the 1/3. Remember your power to a power rule. Those will multiply to a 1, right? 3 times a 1/3. And you have just an x. And indeed, they both simplify to an x. So these guys are inverses of one another. And that is what your Chapter 2 test will be like.